Hello, so the purpose of this short video is to introduce lecture 29 of mcs360 Introduction to Data Structures. So the topic of this lecture is application of maps, and we will go back to Huffman codes. So our example is to build a Huffman code for a word, and the word that we will be using is the word assistant. So what is a Huffman code? A Huffman code is a minimal binary encoding of a string. So we know the ASCII table, so every character is represented by a byte, at least 8 bits. So here in this message you would have a very long bit sequence. But if you know that certain characters, only certain characters occur, then you can do much better. So think of the case when you have only 2 characters in your message, then you can assign one character the bit 0, the other character the bit 1. So this is the base case in our recursive algorithm. So we will make a frequency table of the characters in this word, and you can see that the word contains 3 occurrences of S, so we will put that on top. Then there are 2 letters that occur twice, so A occurs twice and T occurs twice. We put the A first because it occurs earlier in the alphabet, and we do likewise the same for the letters that occur only once, so the letters I and N. So in our Huffman code we will see that the letter S, since it occurs most, will actually occur with less bits than the letters I and N. So the recursive algorithm reduces the general case to the simplest case when you have only 2 entries in your frequency table. And we do this by contracting the least occurring letters. So here the I and the N will be considered as one character, and we will add up their frequencies. So we will say that IN occurs twice, and we will insert it in the frequency table also in alphabetical order. So the IN comes before the T. So the invariant in the algorithm is that the two least occurring characters always are at the bottom, and we continue as long as we have more than 2 rows. So now we contract the T and the IN, adding up their frequencies. That makes it the most frequently occurring character 4 times. Then we have S, and then we have A. We're still not in the base case, and we contract S and A to end up with a frequency of 5, larger than 4, so the SA comes on top. And then we consider this as a message that has 2 characters, and our tree then has the following shape. Now we come back from this recursion and we undo the contractions. So in going from this to that step, we contracted the S and the A. So now we are going to undo this contraction. And that actually gives us already the encoding for the characters S and A. S will be 0, 0, A will be 0, 1. We continue, so here we contracted T and IN, so our tree will get larger as we are separating the T from the IN. And then finally, we will untangle the I and the N. So this gives us the Huffman tree. So the Huffman tree is a binary tree where the leaves are the characters in our message, and we go left. When we go left in the tree, we will remember to write a 0. When we go right, we will remember to write a 1. So the Huffman code is now summarized as follows. S is represented by 0, 1, A by S by 0, 0, A by 0, 1. T has the code 1, 0. I is represented by 1, 1. We go twice right, and then we go once left. And finally, N is represented by 3 bits. So this is the Huffman code. And we use this table to encode the message. So it's the Huffman code for the word assistant. So we use the table to write down the bit sequence. That is minimal for this message. So the table encodes, the tree actually decodes. So if we have this bit sequence, we encounter a 0, we go left. We encounter a 1, we go right. And at that point we are at the leaf. So at this point we write the A and move back to the root of the tree. Then we have a 0, we go left, a 0, we continue to go left until we come at this leaf and we write an S. The same again for these two zeros, and you can check when we have 1, 1 and then a 0, we will write the letter I. So this is the recursive algorithm which combines the frequency table, which is our running application this week in our applications about maps, and also is an application of trees. So this is why this application was also used in the week when we considered trees. The lectures are explaining the code behind it, and the C++ code is posted. So you strongly recommended actually to consider the posted C++ code. That's it.